Hey everyone. So we're on unit 12, and this is going to be about logarithms. It's actually very similar to what we talked about in unit 11, where we're going to be dealing with exponentials again. But this time we're going to talk a little bit more about how we solve some of the math that we wouldn't be able to do using the methods from before. So we'll quickly start with the do nows. Remember, always work on these questions yourself, and then you can use my videos as a recap and refresher. So from here, what we're going to do, we're going to get the bases the same. So the 5 remains the same, but 125 can be rewritten as 5 cubed. From here, I can, since I now have similar bases, I'm going to set the exponents equal to each other. Subtract the 2 over to get 3x equals 1. Divide both sides by 3. And I get x equals a third. They want us to verify, so I'm just going to do a very quick check where I plug in 3 to the 1/3 for x. I'm going to do this by hand, but if you did it in a calculator, you'd be able to see what the correct answer is. So from here, 3 times a third is 1, plus 2 is 5 cubed, which is 125. So we do get a correct answer. Over here, before I can start solving for x, I need to first subtract the 2 over to the other side, get the x term by itself. Just like how I would normally do it in the case of something like this, where I do 5x equals 10, where I would divide the 5 over in order to bring it over and isolate the variable term. I'm going to do the similar thing with the exponent, except instead of dividing it over, I'm going to move it over to the 8 and take the reciprocal of it. Again, very similar to what we would normally do in regular algebra with the divisions. From here, I can then plug into my calculator, or if I wanted to, I could do it by hand. So this is essentially the cube root of 8 to the 4th power. The cube root of 8 is 2. Raising that to the 4th would be 16. And we could just double check, and we would see that 2 plus 16 to the 3/4. 16 to the 3/4 would get us 8. So 2 plus 8 does equal 10. All right, perfect. So down here, we have a function given to us, 2 to the x, and they give us these variables, and they plot this over here. Now what they want to do is they want us to do the inverse of this function. Now, the way the inverse is, if you forgot, is it's something like this. Let's say you had y equals 5x plus 3. The inverse would be you replacing the x and the y. Of course, we don't normally keep it like this, so you would try to move everything to the other side so that we have an equation with y. But that's essentially what we're doing. We're just replacing x with y and y with x. So in the case here, the way it's going to look is that all my x terms up here are going to go in the bottom part where the y would normally go. So this is -3, -2, -1, 0, 1, 2, 3. And then all of these terms go in for x. So this becomes 1/8, 1/4, 1/2, 1, 2, 4, 8. From here, I can plot this. So now when x equals 1/8, which would be right about here, I go to -3, 1, 2, so right here would be my first point. Afterwards, I go to 1/4, -2. 1/2, -1, 1, 0, 1, 0, 1, oh, sorry, 2, 1, 4, 2, 3, there you go. And my graph would look like this. Now, the good thing is one thing to note, we did this right because we should see that it's symmetric about the equation y equals x. All right. So that's kind of where we're going to end up going to. So if we scroll down, they want us to know, how would we write the equation that's the inverse of this? And that's algebraically. So what we would start off doing is just flipping the x and y terms. So for example, in my equation, essentially what I have is y equals 2 to the x. So now my inverse equation will end up being x equals 2 to the y. But again, we want y by itself. We want to rewrite this as y equals something. And that's where the concept of logarithms is going to come in. There's really no way for us to solve the equation for y without doing this. So the thing to note is this. If we have a scenario like this, where it's b to the y equals x, we can rewrite this as log b x equals y. So using my equation here, where originally I had y equals 2x, my inverse would be x equals 2y. My base is 2. So it's still going to be 2. X equals y. So down here, that's what I would write here. Log base 2x is my inverse function. So the logarithmic function is the inverse of the exponential function. And we could go back the other way. If we had a log function, we could rewrite it as its exponential form. The main way you're going to kind of remember how to do this. So in both cases, b is considered the base term. When it's with the log, we would normally call this log base b. And then over here, the b raised to the y power, the b is once again the base. So the way I always do it is, if I have it written in log form, I take the base of the log, move it over, and it becomes the base over here. So you just write it as that. So the b moves over so that it becomes underneath the y instead of being underneath the other one. And then we are left with x equals b to the y. Similarly, if I have my equation like this and I want to write it with logs, I do a similar thing. I take this, I move the base over so it's underneath the x. But because I'm doing that, I have to add in a log term before it. All right. So we'll do a few examples. Basically, you want to make sure that you are comfortable going back and forth to these terms. Now, in these practice questions, that's all we're going to be doing. There's really no variables really that we're going to be solving for. We'll see how we do that later on. So just doing some practice. I have this in log form, so I'm going to take the base of my log, move it over so that it's the base to my new exponent. I drop the log term that was there. So I'm left on the left side with 27. And on the right side, I now have 3 to the third. Over here, similar thing. I have 5 as my base. I move it over to the other side and it becomes my base once more. The log drops and I have 625 equals 5 to the fourth. We can always check in the calculator to make sure this works. and I recommend that you try that, you do that yourself. All right, number 3, 4 is our base. It gets moved over to here. The log drops, so I'm left with 32 on one side, 4, and then I want to be careful, the exponent is 5/2. So that whole exponent is still there. All right. My b term is my base, so it gets moved over here. So I drop my log, left with an n. It's n equals b to the x. All right. Over to here, take the 7 base, move it over here, drop the log. I'm left with 1 equals 7 to the 0 power. Number 6, take the 2, move it over by the 6, drop the log. Left with 64 equals 2 to the 6th. All right, down over here. So 10 is going to be my base. I move it over to here. I'm going to drop my log term. So I end up with 1,000 equals 10 to the 3rd. Over here, 7 is my base. Move it over. Drop the log. 49 equals 7 squared. All right, in these next set, we're doing the opposite, where you have the exponential written. We want to rewrite it so it's in log form now, but the same process ends up working out. So the 2 is my base over here. I move it over here, so it becomes my base once more. But this time I have to add log base 2 32. The 5 that was on the left stays there. All right, over here, take the 3, becomes my base underneath the 27. So 3, add log in front of that base, and I get this. So this says 3 equals log base 3 times of 27 is equal to 3. Over here, take my base term b, move it over so it's underneath the n, add in my log term, and I add that. 4 is my base, moves over to here. 2 equals log base 460. So you should start to see a pattern, and hopefully after doing enough of these, it should become pretty straightforward how you do this. Really quickly, if you're going to do this in a calculator, you have to make sure you put parentheses around that number, just so that the calculator reads it properly. While I go through these, I just want to quickly mention, when you're using a calculator, if you see something like this log without a specified base, the base is actually supposed to be 10. So this is, if they don't tell you what the base is, it's assumed to be base 10. If you wanted to do a log function of a base that's not 10, like these examples here, you have to be careful with plugging into the graphing calculator. You have to actually go to the math section on the calculator and look for log base near the bottom. And this will allow you to add in a different base other than 10. All right. So continuing on with this, 10 is my base, moves over to here, 2 log base 10 of 100. And then this one, all right. So what I want you to do is, I'm not going to go over the independent work because it's very similar to the homework and everything that we've been doing. So I want you to submit the independent work as well as everything else. So you should be submitting in your do now answers, your guided practice answers that we've gone over, independent work, and homework. All right. If you have any questions, feel free to let me know. Otherwise, good luck and have a great day.